Hello everyone in CSC-134 C++ programming. Welcome to the next to the last week of class. We finish up Module 7 this week on searching and sorting arrays and vectors. I'll review a little bit of what we were doing last week and then introduce you to what is due this week, as well as pointing you to 3 different videos about different ways of sorting arrays. And so before we get into sorting, let's kind of review what we did last week. We looked at 2 different types of searches. The first type was a linear search that basically just starts at the beginning and goes all the way through until it finds what it's looking for. That's a very inefficient way of searching. If you think about it, if we had to search, let's just say 1 million tax records for your county, if we were doing a linear search, we would start at the beginning, and if your last name was, say, Williams, you'd go through almost all of those 1 million records before you would ever get to the one that you were looking for. So that's the linear search. We discourage using the linear search in the real world unless the array you're searching is just really short. The better type of search is a binary search. And a binary search works by splitting the array in half and then looking to see if what we're looking for is in the first half or the second half. And then if it's in the first half, it will split the first half and check both halves again. And so it walks its way down pretty quickly until it finds something. And so that is a much better way of searching. And last week I showed you ways to do both kinds of searches, and I showed you the algorithm library search that's not in your book at all, that is much simpler to implement. So when we were talking about the binary search just now, make sure that you understand that the array has to be sorted for a binary search to work. We couldn't split the array in half and check to see whether what we were looking for was in the first half or the second half by looking at the last part of the first half and the first part of the second half. We couldn't look at those things if the array wasn't in order. We would just, if the array is not sorted, if it's not in some kind of order, then we would have to use a linear search. So if you're going to do a binary search, it has to be put in order. So, and when I say that, if it's letters or alphabetical stuff, then it's in order A to Z. If it's numbers, it has to be in order 1 to, however many, from smallest to largest. So, if you're going to do a binary search, the fast kind of search, remember the array has to be sorted. Okay? So, both kinds of searches have to read things from the arrays. We went through these searches last week. You have to use those searches in Project 10. Project 10, if you have taken programming and logic with me, you probably had a pizza program. that's very similar to that what we did in Python with 3 synchronized lists. Here in C++, you're doing the same thing with 3 synchronized arrays. So you have to find what you're looking for in the first one, wherever it was located, what index or position it was located in. You find that, use that position to find the related things in the other 2 arrays. So that's got you caught up to this week. Before we talk about the videos up there, I want to make you aware the exam for Module 7 is due this coming Sunday, May the 3rd. There are only 20 homework questions, so you would want to do those before you do the exam. And Project 10 is due at the end of this week. So you got 3 things that are due this coming Sunday. Once we complete Module 7 at midnight on Sunday, May the 3rd, the final exam for this class will become available. You will have all week to do that final. The final is multiple choice, true, false final, so you don't have any code to write, and you'll have all of next week to do it. Not next week, but the week after. So here we are on the 26th right now when I'm making this video. You will have until May the 3rd to get the materials finished for Module 7. That's the homework, the exam, and Project 10. And then at midnight on the 3rd, the final exam will be available, and you will have until May the 8th to get that done. May the 8th. So look for the final to show up. That's 10% of your grade. Look for it to be out there, and you will have 5 days to get that final done. Don't forget, it will lock and go away on May the 8th, and that is a Friday. So plan ahead. You have 5 days to get that done. That one test. Okay? Alright, so here we are. We're caught up to this week. Watch this video that simulates how the bubble sort works. And then I have given you code that shows you how to implement the bubble sort. The bubble sort is going to be your least efficient sort in almost all cases except one. And they do try to trick you up on this in AP computer science exams, and maybe somebody gives you an interview question and they say, of course, one of the interview questions might be, if you're going to do a binary search, do you have to do anything special? And of course your answer should be that the array has to be sorted, or whatever you're binary searching has to be sorted. But if they ask you which search is most efficient, which sort is most efficient, the answer is it depends. If the information is already sorted, or maybe just the first 2 elements are out of order, then the bubble sort's going to finish faster. But that's the only time it would ever beat any of the other sorts is if the information were already sorted, or it's almost perfectly sorted. So that's when the bubble sort would win. The other searches or sorts, like the selection sort, that's a little more efficient, than the binary, or excuse me, than the bubble sort. The selection sort's a little bit more efficient than the bubble sort. And so if your book asks you a question of which one is more efficient, obviously the selection sort would be more efficient. And you've got a video that shows each one how it works. Now, in the module material, I've given you code for both of these. I'm going to do another video that shows you how to use the algorithm sort. And I'll just go ahead and tell you, if you look at the amount of code that it takes to implement a bubble sort or a selection sort, you will see that it's a lot of code. It's a lot of code. Sorting is probably one of the things that makes people's heads hurt the most. So these folders right here, I'm in module 7 looking at the folders. I put the videos there both places, but if you click into this folder, then you've got my actual code and how I talk about the way this works. Now, down here, this is the code right here for a bubble sort. You can see how much code that we've got going on. If you watch the video, you'll understand what the code is doing. Okay? Now, the selection sort, which is more efficient than the binary, or excuse me, than the bubble sort, but it's even more code. There's all the code right here. This is all the code for a selection sort. Now, if you watch the short video that I will do next, I'm going to show you how to do this with about one line of code, except for the function brackets and the function header. I will show you how to use the algorithm library, and instead of doing all this, you'll have 1 or 2 lines of code. And not only that, but your book doesn't even show you how to do a binary sort, a binary tree sort, which is the most efficient of all. And guess what kind of sort the code that I'm going to show you in my video does? It does the binary tree sort. So not only is it the shortest amount of code, but it is also the fastest. So I will do that video next, but I wanted to go ahead and talk to you just like you were in the classroom. And so now you know what we're up to here in this week. You know the exam is due Sunday evening of this week, along with Project 10 and the homework. Remember that your lowest project grade gets dropped. Your lowest exam grade gets dropped. Now, we don't drop the final exam. The final exam's worth 10% of your grade. So, I sent everybody a video. I sent everybody an email about their grade in the class, so you should know where you stand. I have a few items left to grade, but I will try to get those caught up on Monday. So whatever grade is showing out there is your grade as of this moment. It can't go down. It can only go up. So have a good next to the last week of the semester, and we will be putting the final exam out there for you guys and girls on Sunday night, May the 3rd. Have a good week.